Guys, I hope everybody is fine and today we'll be talking about the universe again. And we'll be talking about the universe that basically remembers everything. There is not anything in the universe that's lost. This is the argument and we would like to talk about it. And and suddenly there is something terrifying. There's something terrifying about forgetting a face, say for example, a face you once loved, that face slowly fades. That face is slowly fading. A childhood memory that becomes blurred. So there's blurring of the memories of the when we used to be uh, the childs. A voice disappearing from your mind forever. Human beings, we human beings are we are obsessed with preservation. And the proof of that is what we do is we write books, we build monuments, we build we record videos the way I'm recording it right now. We try to save the photographs as memories because somewhere deep inside us, somewhere deep inside, we know that time keeps on erasing things. We experience those things. That's why we try to save out all these things. Or at least that's what we believe. But in fact, today I want to challenge that belief. I want to challenge that argument because because according to according to science, or more precisely, according to modern physics, the universe may not forget anything at all. This is the argument. So not even my voice, not even your voice, not even your actions. It won't do that. It won't lose it. I mean, not even the smallest movement of a single atom. And this, and if this idea is true, if this argument is true, then reality itself is something, it's far stranger than we ever imagined it. Because maybe the universe is not fundamentally made of matter. And maybe it's made of it's made of information. It's filled with information. Every time information is added to it. You imagine, if I imagine walking alone on a beach. When you walk on the beach, what we do is you leave the footprints behind you in the sand. And for a brief moment, for a small span of time, those footprints exist. Then a wave from the sea a wave from the sea arrive. A water wave arrives. The water washes over the shore. And suddenly the footprints, they're gone. To your eyes, the information has disappeared. To our eyes, the information is gone. But what about physics? But what physics says is perhaps extraordinary, is perhaps an impression. An extraordinary thing has happened. What's that? Every grain of sand interacted with trillions and trillions of water molecules in a very, very precise way. Energy they were carrying, energy was transferred. Heat was redistributed. The atoms collided. They collided according to the exact mathematical law. What does that mean? That means the footprints did not vanish. Its information simply, it has spread outwards into the environment. Even though it's becoming impossibly difficult to reconstruct the pattern, to reconstruct the footprints that were there for that small moment of time. And this changes everything. It changes everything because what we call distraction may actually be nothing more than information. And that information scrambling, that information spreading. So what does it mean? It means footprints are not erased. They're not erased. They're just hidden. They're just hidden. Now think about this. Think about the argument carefully. When you speak, when I speak, your voice creates vibrations in the air. There are vibrations in the air. And what happens to these vibrations? These vibrations move. They move outwards. They move outwards forever. And what happens to them is they become weaker and weaker. They keep on becoming weaker and weaker. But in principle, they never completely disappear. They do exist, even though their amplitude is extremely going down and down. Every photon reflecting from my face right now carries information. It carries information about me, about you into space at the speed of light. Right now, an expanding shell of light containing your image. Sorry, is racing away from Earth in all directions. I beg your pardon for sneezing. A version of you from 5 seconds ago already exists billions of kilometers away from this room. The universe is continuously recording. It's recording the reality. It's not doing it, it's not performing this action metaphorically. It's doing it exactly, it's doing it physically. A set of photons interacting my face, reflecting back, billions of them going outwards. And suddenly, the deeper physics went. The stranger this idea becomes. Because when you try to go deep and deep, it becomes more strange. Let's come back to that classical argument. In classical physics, if you know the exact position and motion of every particle in the universe, what's going to happen? You can exactly predict the future. And at the same point of time, you can reconstruct the past. Reality behaves like a gigantic equation unfolding through the evolution of time. From a classical point of view. But when quantum mechanics arrives, when you think about the same argument via quantum mechanical laws working at microscopic level, and everything becomes even more mysterious. It becomes more mysterious because in quantum theory, information is sacred. There is a principle called, we call it unitary evolution. And at its heart lies a shocking statement. And what the statement is? The statement is that information cannot simply vanish from existence. Physics allows the transformations. The laws of physics, the laws that are dictated, it allows these transformations. It allows chaos. It allows explosions. It allows the collapse of a star, a collapsing galaxy, and the colliding galaxies. But it does not easily allow a complete deleting an information. And suddenly the universe is no longer looks like a machine made of objects. It basically begins to look like some cosmic memory system. It's not losing anything, it's recording anything. We call it a colossal, gigantic, a giant recording process unfolding across space and time itself. Now think about throw a stone. You throw a stone into a pond. Say, let's take a pond. Throw a stone into a pond. What happens is ripples are formed, and these ripples spread outwards across the water. Now, eventually, what happens? Eventually, the surface appears calm again. You have ripples, and then again there is a calm. But the energy never truly disappeared. The motion, the motion transferred into the small vibrations. And the tiny molecular movements, heat, the information survived. The information survived in the form of heat. I may say it's hidden inside that complexity. It's not lost. Now let's try to scale this idea up to the universe. We started from the argument of a small pond dropping a pebble of stone. Now, when we think about the stars, when stars explode, what happens? The space-time curvature, the space-time vibrates. When two black holes collide, what they do is they send gravitational waves. They send the ripples of gravitational waves across the cosmos. And these distortions are very tiny. I may say tiny distortions in space itself travel for billions of years, carrying information about the collision, about the events from the ancient universe. As I quote here, in 2015, humanity detected gravitational waves for the first time. They were predicted mathematically by Albert Einstein. And we literally listened to the space-time ringing like a bell. Now think about how unbelievable that is. What am I trying to tell is, you have two black holes. The two black holes, and they are colliding over billions of years ago. And the universe still carried the memory of that collision all the way to this tiny planet, Earth. So what happens? Reality remembers. But then, if you go on, but then physics encountered a terrifying problem. What's that? Black holes. And these black holes, they are the darkest objects in the existence of this cosmos. These are the places where gravity becomes so intense, the gravity becomes so extreme that not even light can escape from its surface. For decades, scientists, they believed black holes were the universe's shredders. Now throw anything, subject anything into them, maybe a planet, a library, or an entire civilization, and the information would be lost. it would be lost forever, an hour, an hour. And that idea horrified physicists because if information can truly disappear, if information is lost, then the laws of quantum mechanics, they break. The laws of quantum mechanics break apart. And then you have the man, and then you have Stephen Hawking. And this man made things even stranger. Why? Because he discovered that black holes are not completely black. What they do is they slowly, steadily, they leak. They leak radiation. And leaking radiation means they evaporate. And if they evaporate, they die. Now think about the nightmare that this thing is creating. And what's the nightmare? If a black hole evaporates completely, what happens to everything that fell inside it? A planet, a civilization, a library. Where does all that information go? Does reality literally forget? This becomes one of the greatest puzzles in modern science, the greatest puzzle in modern physics. And what's that? The black holes, what we call it as the black hole information paradox. And what can be the possible answer? And I would tell you here, and the possible answer is almost impossible to believe. Some physicists now think the information never truly enters the black hole at all. And instead, it may become encoded. It may become encoded on the surface boundary, what we call as the event horizon. And this idea, the idea of event horizon, evolved into something called the holographic principle of black holes. And if this principle is right, if this principle is correct, our entire universe may work like a hologram. What we experience as three-dimensional as a three-dimensional world that we have. And it could actually emerge from information written on a distant cosmic boundary. Think about how how radical this is. I mean, you, I started from you, your memories, your body, the stars. Think about it. It's you, then your body, then stars, then galaxies. Everything, everything you have ever touched may ultimately be patterns of information, not solid objects. In a way, we intuitively think about, we intuitively imagine. But as I keep on saying, patterns, encoded reality. This is how we can interpret it, we can think about it. Now let's turn inside. I mean, let's turn inwards. Why do we remember the past but not the future? What's the reason for that? We don't remember the future. We always remember our past. And why does time feel, it feels like it moves in just one direction? It goes on and it has the footprints of the past. And it quickly brings us to the argument of entropy, what we generally know as the second law of thermodynamics. And what second law of thermodynamics tells us? It tells us that the universe naturally moves from order to disorder. If I have a glass, a glass falls and shatters. The shattered glass, but the shattered glass never spontaneously jumps back together. Think about an egg. You have an egg, you leave it, it breaks, but it never unbreaks itself. It does not go back into the order. Now, the question is why? Why this thing is happening? The answer is because the information required to reverse all those microscopic motions, we can say it like this, all these microscopic motions becomes overwhelmingly distributed. It becomes impossible to gather that naturally. The future contains more possible arrangements than the past. This is how we can interpret the second law of thermodynamics, which states that the entropy of the universe goes on increasing. And this creates what we call the arrow of time, as I have talked about it many a times in past. Time itself may actually be tired. It might be tired to the spreading of the information. Memory is not something that you can separate from physics. Memory is not separate. It's not separate from physics. Memory itself may be physics, may be the laws of physics. Your brain is constantly recording. It's constantly recording irreversible changes in matter. Neurons rearranging themselves, rearranging, and connections. Somewhere the connections strengthen, somewhere the connections loosen. You have the patterns, you have the electrical patterns, and these electrical patterns, while these neurons keep on evolving, every memory you possess is literally a physical restructuring of the universe. And now comes the haunting part. The very haunting part. Every interaction leaves traces. Every touch, every photon that's touching my skin, every word that I'm speaking right now, every moment, maybe every moment of love, every moment of pain, all of it, it changes reality forever. It changes reality to a state where it cannot come back. If only by the smallest amount imaginable. This is how it works. This is how it feels mathematically. And then what happens? And then quantum mechanics introduces one final mystery. And this final mystery that comes from the quantum mechanics is observation. In quantum world, particles exist in strange clouds of probabilities until an interaction occurs. This can be the most feasible argument about the predictions of quantum mechanics. And somehow measurement changes the outcome. And this is what is called as the act of observing, becomes the part of reality itself. The action. We generally have the knowledge about that. We know about the Schrodinger's cat, which means consciousness is not merely watching the universe. No, it's basically, it is participating in it. Every observation becomes a new chapter in the cosmic record. And that really makes it complex. That really makes it inaccessible. And suddenly you begin to see yourself differently. This is what's called as observation effect in quantum mechanics. You are not separate from the universe. You are an event occurring in the universe. You are an action. You are a tide. You are a bubble. And what you are doing is You're doing it inside the memory of this universe. A temporary arrangement of atoms. The arrangement that is there for our lives, these atoms are arranged, and their manufacturing has happened in stars. And now we have become conscious and started reflecting on its own existence. And this all existence is from that fundamental reality. We call him God. So we have different arguments, but there is that fundamental reality. And we begin today with this simple question. And what was the question? The question was, does the universe remember? And physics gives us a deeply unsettling response. It gives us a deeply unsettling answer. The past may never truly disappear. Its existence is always there. It survives. It survives in scattered photons traveling through the space. In thermal radiations that are there because of heat energy. In quantum mechanics, we have entanglements. In gravitational waves, they're crossing the cosmos at very, very large scales. In the microscopic domain, in the microscopic world, rearrangement of matter. And that arrangement leads to some patterns. The universe may be gigantic archive where nothing is ever completely lost. It may break into the pieces, but it's not lost, not really. And if there were some unimaginable intelligence, maybe capable of seeing reality in totality, in all its domains, in all its framework, it might see every moment of existence simultaneously. So every star that is ever born, every civilization, come back to this dot in the solar system, every civilization that you have, every heartbeat that we have, every word you have ever spoken on this planet is still present. It's still present. It's not gone. It's not destroyed. Just it's all woven into the structure of reality itself. So we have had a long one-dimensional conversation, and I hope one day you will disappear. I will disappear. Your atoms will scatter. Your voice will fade. It will fade from rooms. your photographs will your photographs will age, but the physics has a different suggestion over here. Physics suggests something extraordinary. And what it suggests is the universe will still carry the imprints that you were, here on this planet, and it would have caused a permanent disturbance in the space time. It will act as a signature. It will act as a signature written into the reality. You are temporary. You are temporary, but your existence, your structure, your existence is not meaningless noise. You are part of the memory of this cosmos. You are the part of the woven memory of this universe itself. And I may go further from here, and perhaps that's the closest thing physics has ever found. Physics has ever predicted. Physics has ever mathematically predicted. It has predicted to immortality. So with this, I hope you like it, and goodbye.